So far we've drawn some Lewis structures, but organic chemists rarely draw things with Lewis structures. So I'll go through some variations of different structures and eventually kind of lead to the structures that we use the most. So one variation are the Kekule structures. And Kekule didn't change very much. They're really just Lewis structures. And I've kind of already been doing it because it's hard for me to continue to draw Lewis structures. And in Kekule structures, the lone pairs and bonds, or bond pairs, are shown by short lines. Instead of a dot meaning each electron. So an example of that would be that if I had methanol, I could have C, H, H, H. Notice that I don't have dots anymore. I'm doing lines, O, H. For example, instead of having it be C, H, 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 dot, dot, O, dot, 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 H. So that's a true Lewis structure. This is Kekule's version. It's just a little bit faster drawing. And we don't use Kekule structures very much. There is one kind of structure that we do use from time to time. And those are called condensed structures. Condensed structures really are easy to use when you're typing things and type text kind of things, and that's what makes condensed structures useful. In condensed structures, the bond lines are omitted, and we use parentheses to show grouping. And lone pairs are also omitted. So I can do the same molecule as above, which was methanol, and write it CH3OH. These three hydrogens are attached to the first carbon, and this hydrogen is attached to oxygen. We can do bigger molecules. I can do CH3CH2CH3. That would be propane. And it's faster than drawing out the Kekule structure. And to use something that would have parentheses, we could have CH3, 3CH. So what that's saying is that there are 3 CH3s attached to that carbon. So we've got a carbon with a hydrogen on it, and there's a C with H, 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 another C, and yet another C with 3 hydrogens on it. So the Kekule and condensed structures have their uses, and we will still draw them from time to time, but by a huge margin, the primary structures that we'll draw in this course are going to be skeletal structures. So that's the way that organic chemistry is written. If you open up any book or any journal or anything that's looking at organic chemistry, the way that things will be drawn will be with skeletal structures. There's a set of rules for skeletal structures, so I'll set up the rules first and then I'll show you how they work. So the first rule is we assume carbon at the beginning and end of every line. Unless it's labeled differently. Two, we assume that all carbons have 4 bonds unless charged. 3, all unshown bonds are to hydrogen. And that's going to be really useful because there are a lot of carbon-hydrogen bonds in organic molecules, so we don't have to draw those bonds in. And 4, heteroatoms, things other than carbon and hydrogen, all must be labeled. All other atoms must be labeled. So let's look at a few examples. So I'll start with a Kekule structure. So let's take something like butane. We can draw the condensed structure of that. Start at the left, it's a CH3, followed by a CH2, another CH2, and another CH3. So that's definitely faster than drawing out the Kekule structure. And if we're going to draw that in a skeletal structure, wherever I start at carbon, 1, 2, 3, 4. All of those are exactly the same structure. They're all the molecule butane. Hopefully you can see how much better the skeletal structures are for how easy and fast they are to draw by comparison to all the other structures. So you can do the same thing for something like an alcohol. So if you have CH3, CH2, CH2OH, so that would be propanol. There's 3 carbons and an OH. 1 carbon here, 1 carbon here, 1 carbon here. So there's 3 carbons followed by an OH. Notice again, any atoms that are not carbon and hydrogen have to be labeled. And hydrogens that are on a heteroatom have to be labeled. If hydrogens are attached to carbon, we don't have to label them.